Hi everyone, I want to use this animation to point out a few things about heat transfer. I think it'll help you visualize things we've been discussing in class. So something that we introduced last night was kinetic energy, and energy is the measurement of, is used to measure temperature. So if something is considered hot or warm, it has more kinetic energy, and something is considered cool, it has less kinetic energy. So if you allow these little E's to represent the kinetic energy, we can see how the energy moves from hotter things to cooler things. So let's look at what happens when we put the two cubes together and look and see what happens with the energy involved in the individual cubes. So here we go, we put them together and the energy is transferred. Energy is moving from the first object to the second object. We call that transfer heat. So what we're really doing is transferring energy as thermal energy. So we know that heat is not a substance. A good way to think about this is that we're looking at thermal energy, and energy is transferred as heat. And that is what's going on when you see these E's moving from one block with a lot of energy or a higher temperature to another block with not a lot of energy or a lower temperature. And we're going to move to another idea, and this idea is called specific heat capacity. So different items, different things have the ability to transfer heat more easily or with more resistance depending on what you're looking at. So in this example, you're going to see the same amount of iron and water. These two are the same amounts, and they're both put over a heating device. And now we will apply a situation to both of these things. So we increase the heat or the energy. You see an increase in temperature in the iron. And if we put some ice underneath the water, we're slowing down the molecules in the water because the heat energy is leaving the water. As you continue to watch, you'll see as the energy moves. Now watch as the energy symbols are showing you the direction that the energy is moving. The energy is leaving from the fire into the iron, and it even leaves to the environment. And when it's cooled down, the energy transfers from the water into the ice cube. And then if we take the iron and we put it into the water, because the iron was hotter, the energy actually leaves the iron and to the surroundings. So that little demonstration that I just showed you reinforces what we talked about today, that when we look at the system and we look at the environment and we ask ourselves the question, is it exothermic or endothermic? Well, the energy is moving from higher energy to lower energy, but we also always have to keep in mind the point of view of which is the system and which is the surroundings. So this shows you that if you consider the water the system, then heat is moving from the surroundings into the system. So it's endothermic because it's moving into the water. Or if you consider the flame the system, then heat is moving from the flame to the surroundings, so it's exothermic. So envision those little E's moving depending on which system you're thinking and talking about. So then there's this idea that we're going to start to introduce called specific heat and specific heat capacity. And the specific heat capacity depends on the item that you are looking at and talking about. So AU is gold, AL is aluminum, H2O is water. And each one of these has a different ability to transfer heat. Imagine you have a kilogram of gold, a kilogram of aluminum, and a kilogram of water. And we're going to look to see how much energy is transferred through each of these items. And each one of them are in a container, and they have different amount of specific heat capacities. The unit is joules per gram times Kelvin, degree Kelvin. Low specific heat capacity means the amount of energy it changes more readily. This water has a higher specific heat, so the amount of energy that changes is not as readily available. So just to be clear, the same amount of energy was put into the gold, the aluminum, and the water. It's just that the specific heat is lower for gold, so that means that the temperature changed, where the water, the same amount of energy was put into it, but the energy did not change the temperature of the water because it takes, the specific heat is higher. Just to be clear, the water was able to absorb more energy before its temperature started to change. So that's just a quick introduction to specific heat and how it relates to the transfer of heat, which is what we started talking about. Let's talk more about this tomorrow. See you all in class. Bye.